Thank you for joining me. Thank you for joining this integration testing with Spring talk. I'm Catalin Tudose. A few things about myself. I have a PhD in computer science, and I'm currently acting as a Java and web technologies expert at Luxoft Romania in Bucharest. Also, I am an author of 6 courses and 1 project at Pluralsight. I'm author at Manning. And I have already published this book, JUnit in Action, published November 2020. For this year, probably for summer, we are scheduling to publish this Java persistence with Spring Data and Hibernate. So these are a few things about myself. To quickly move to our today topic about integration testing. Just to feel what integration testing is, we will look at this testing pyramid to place the integration testing and to understand what it is about and why we should care about it. You see this pyramid that is having in the ground the unit testing. When we talk about unit testing, we talk about testing methods, about testing classes, in general of testing units of work. But as we don't work in isolation, we care a lot about integration testing, about testing the integration of our functionalities, of our code with external systems. And here we think about integration with some services, about integration with some databases, and we'll have a lot of demonstrations about integrating with databases. In the upper part of the pyramid, we may talk about system testing, about testing the whole system, and about acceptance testing when we talk about testing so that the system proves to be useful for the end user. But we focus here at this level of integration testing, and this is our target for today. And as I was saying, we are going to demonstrate our examples with Spring and testing some work with an external database. Which are the tools that we have available? Spring TestContext Framework. It is a generic annotation-driven integration testing support, so it doesn't care about the testing framework. And for our demonstrations, we are going, of course, to combine it with a JUnit 5, which is the latest JUnit version, and of course, it is the most widely used. So I'm going to switch here to the code demonstration. What do we have? What do we test? We test the integration from this code from this application here with a database that we have here in MySQL, and we chose a real database. And we have, for our purpose, for our demonstrations, we have a simple application with 2 entities, user and log, and 2 corresponding repositories here, meaning that I would like to interact with the database with the use of Spring Data and of these repositories. And I wrote here a test that I'm going to launch now. It is doing something very simple. We write here test, and what we are trying to do, we are trying to create a user as an entity and to save it to the database. Then we try to find it, say, okay, if the user is there, it should be there because we saved it, and we conclude our test to be successful. And this seems simple, but we should ask ourselves what's happening with the database after the test, which is the state in which we are leaving it. And if we will try to repeatedly run this test with the help of this nice feature from JUnit 5, which is a repeated test. So you see here that I'm saying let's run the test twice, repeated test with argument 2, I should expect probably to have the same successful behavior. But we're saying we didn't think about what is happening in the background, what is happening with the database. And you see here that the first repetition is fine. And the second repetition will say, I was expecting one record here, you see it, but I have received 2. And this is a problem. The problem is that we didn't care so far about what's left in the database after the execution of our test. So from the execution of the first test, we had something that remained the first record. So at the execution of the second test, the second record was found there and our test failed. So we don't integrate so fine with the database. Which are the alternatives? Which are the solutions in order to help us integrating with the database? A first alternative is to use what is called dirtiest context, and we have this dirtiest context annotation that I'm going to use. What are we telling here to the test? We are telling, hey, when I executed it, I dirtied the context. So the underlying Spring application context has been changed as a result of the execution of the test. So you should reinitialize the container, recreate the container for any test that needs the context. And if we go back here, I'm waiting for this. So I should say, if I repeat the test twice, I should expect that the container should be recreated each time, and we should reinitialize the application. And as a result, I will not have anything left behind. So you see here, the second repetition was also fine. But what we should be aware of is that we are paying some time, because as we reinitialize the context every time, this takes time. And to demonstrate that we are reinitializing the context every time, we see here the Spring boot banner the first time and the Spring boot banner the second time. It is like running the application twice, and this takes time. So dirtiest context may be a solution, but it comes at a cost from the performance point of view that is pretty high. Most likely, you may use it locally, but if you push your code to execute tests with dirtiest context on the continuous integration machine, that will not be a nice alternative, because it will take a lot of time. If we have here a look at how the dirtiest context functionality is, we see that it is a loop, and for each repetition of the test, we create the context and cache, and after executing everything, we remove the cache context and so on. So this is clearly a time-consuming process, and we are going to have some performance analysis a little later. We would like to look at the alternatives. And another alternative is to use transactional execution. So what is it about? I am having a pretty similar test. I am already adding here repeated test twice. Yes, I am going to execute it, and instead of using this dirtiest context, I am using this transactional annotation. What do I mean here? It means that each execution of the test will be transactional. At the end of the execution of the test, the transaction will be by default rollbacked, because of a listener that I'm going to go back to the idea of a listener. There is a listener that by default will roll back the transaction. And at the end of the execution of each test, as we roll back the transaction, we leave the database as it was before. So we execute, we test the consequences, we test that we have obtained this result and that result, and at the end of the execution, we are going to roll back the transaction. This is a little better, at least from the performance point of view, from the point of view of the time of the execution, but we also have to pay attention to something. I'm going to demonstrate here one situation when we may still dirty the database behind us. We talk about the transactional annotation from Spring, and we talk about the default argument of transaction, which is required. So what I am doing here is that when I say transactional, I say by default required, so Spring will start a transaction if it was not started. But I'm forcing here my lock. And you see here that I am isolating this transactional method that is also having the transactional annotation. If it was propagation default, it was required, it means we started with a transaction from this test, we continue with the same transaction, but we would like to force our luck here and say propagation requires new. This means that we are trying to force the behavior here. We are in the transaction from the test. We separate here a transaction, a second transaction that may be committed or rolled back. It has its own behavior, but it will be committed. We go back to this first transaction that was initially suspended. We continue it. And if we have a look here, we see that the second repetition of the test is failing because it says, hey, I was expecting 100 rows because we tested with many rows here. We have here 100 iterations, but I was getting 101. Why? Because this execution from here, from here, is indeed transactional, but being in a separate transaction here, the transaction is not rolled back. It is committed. I still manage this transaction original by rolling it back, yes, but this separate record remained in the database. We dirtied the database. And at the second execution, it will find this additional record, which is not good. So we may still encounter some problems even with transactional. If I have here a look at this, you see here, this is the remaining record. We had 100 records and this one separate record that was not, whose insertions was not rolled back. So that's not good. We have to pay attention as a conclusion, we have to pay attention to using transactions, because by using a wrong propagation option, we may still harm our integration tests. But in general, we may say that transactional is something to be preferred over the dirtiest context. Because as I was saying, we are presenting now some tests, some performance tests, and we executed a series of 10 tests here. And what you see here, on 100 up to 2000 records, you see that the execution time for MySQL for using dirtiest context is always greater than the execution time for transactional. The same situation is on H2. But what it is really remarkable is that the difference that is illustrated by this third bar here is approximately constant. Even if we add more and more records here, and the overall execution time is increasing, the difference between the execution with Dirtiest Context and with transactional is pretty constant, because it does not depend on the number of records, but on the number of tests. If we use Dirtiest Context, we reset the context at each execution. This takes time, and this time is reflected in this difference here from the third bar, which is approximately constant because it only depends on the number of tests. We still have something more to say here about transactions and about transactions management. The Spring framework context will come here with some particular annotations that we are going to briefly review before transaction, after transaction, rollback, and commit. And we can take a look at some examples and see what may go wrong and what we should take care about not to do something to affect our integration tests. Just to mention here that there is some execution time test here that I'm not running right now because of the time constraints. You have the results summarized in these two graphics, and of course you will be able to find everything here on GitHub. You can run everything by yourselves. I just presented here the results of the execution of the performance tests. Coming back here, I was saying that we still have some other tests here that would like to demonstrate some separate annotations before transaction, after transaction, and we may have this rollback or commit annotations. I was saying that by default, if we are having this transactional annotation, the transaction will be rolled back at the end because there is a listener that will do it, and we are going to come back to this idea. So if I'm executing this test now, I'm expecting before the transaction, you see I'm using this nice feature of JUnit 5 saying assumption. I want to make sure that if I have here before transaction, I'm really outside of a transaction. So I'm assuming that I'm not inside the transaction. While here, the same thing. After transaction, I should assume, yes, I am not in a real transaction. What can we vary here, or what can we do wrong? For example, I'm going to force here saving some log objects. So objects of some other type, not user. We're previously working only with user entities, and we're saving them to the database, and say, okay, I need something to do, and I do this mistake. I am saving here in the before transaction and after transaction annotated methods. I am running now this test. Let's see how they go. Tests are fine, but I left something dirty behind me. If I look here into the user table, I'm selecting everything, nothing is there because the transaction of saving into the user has been rolled back. While if I select here from the log, you see I am leaving behind me these records, which is not what I intend. I want my tests, my integration tests, to be predictable and to be safe and sure, if possible, close to the unit tests, close to the safety of the unit tests. And if I am doing here something of this kind outside of transaction, I may dirty and I may affect what's left behind me. And I don't even know about this because this was done outside the transaction. The tests were successful. I was saying that by default, there is something that is a listener that is rolling back the transaction. I have here the possibility to say, let's change this default behavior, and I may write either rollback false or commit. It is the same thing. These are annotations from this Spring framework testing that we are using. I can force to commit at the end of the execution of the test, which is not the default behavior. Let's see what is happening. First, repetition works fine. The second one, of course, it is failing because it encountered a record previously saved by the first test. And if I go here and remember that table select, that user table was empty at the end of the execution of test. Now, if I say select all from user, I am getting this 200 records. I left the table dirty behind me. Most likely, this is something that I will not do in practice, only for debugging, because real tests, fancy tests, good integration tests don't leave things of this kind behind them. We would like to be safe, as I was saying, as safe as possible, as close as possible to the unit tests. So this is about the basics of how to approach this integration tests, but we have a few more things here. About test execution listeners, I mentioned them. I mentioned that there is a test execution listener that is following the execution of our tests, and it is rolling back at the end if the execution is transactional. Let's see something more about the test execution listeners, and if we can do something more. I left this, I prove here that I left my previous tests in a good shape. I have here this second example, and I was saying that I may be able to write my own execution, my test execution listener, by implementing this interface. If I have a look in this interface, we see here that we have a few default methods. Yes, they are not implemented, so I don't need to implement all of them. I will implement only the ones that I need, and for the purpose of our demonstration, we implemented many of them to demonstrate how things are going. You may ask yourselves, why should I use test execution listener when I have those lifecycle methods annotated with before each, after each, before all, after all? It is more flexible. If I have some repetitive behavior to put in before each and after each, for example, I need to go to many classes to repeat myself, or I need to create a base class to extend it and to extend it through the other test classes. And this is not so flexible. While with this database operation listener, I am externalizing this behavior here. And I go here and I am annotating this test. Let's say it's still transactional. I may use Dirtiest Context, but I concluded that transactional is more efficient. And I say, let's use test execution listener, database operations listener. And if I am executing, let's see what is happening. So I added my listener, the test is failing. And if I look here, I will see null pointer exception, user repository is null. What is happening in fact here, and I wanted to prove it, is the fact that right now I am having only one listener that is registered. Which one? Of course, the one that I added. Why? Because by default, if I come with my own listeners, the default listeners will not be registered. So for our demonstration, I am going to add here by hand the dependency injection test execution listener that was taking care of auto wiring this repository. And I'm re-executing it. Let's see. It seems that the test is fine, but you see here, I inserted some debug messages about following the transactions. The transaction is not active during the execution of the test because now I miss this transactional test execution listener, even if I have this test annotated with transactional. So if I will have a look here, you see I'm leaving again something behind me, and this is not good. But what I can do here is also register this transactional test execution listener. Let's rerun the test and let's check if the transaction will be active, when it will be active, and if we leave something behind us after the execution of the test. This is our main purpose. Have safe test and do not leave dirty things behind us when we work with the database. It says here, okay, I am fine. So let's see, transaction active is not active at the beginning. Here, before the test execution, the transaction was activated. So as I am coming here with this transaction active, I can follow the execution, the transactional execution of the test. And if I go here and I say select all from user, you see that I'm not leaving anything behind me. That's good. Now, let's check the size of our listeners, 3. And you may ask, okay, should I always come with to add by hand all these listeners that were previously existing if I come with my own? And the answer is no. We did this for the demonstration to clearly demonstrate that when I come with a listener, with my own listener, the previously registered listeners are disappearing. But I may have this merge mode here option. This merge mode saying, let's merge with defaults, meaning take your listener and merge with the default ones that were already provided by Spring. And if we have this execution here, what we would like to demonstrate, not only that the test is running fine. This is one purpose. Do we leave anything behind? Of course not. But if we look here and we say, okay, do we have, how many listeners do we have? It's 15 listeners. The one that we have created and some default listeners, among which, of course, we are going to find this transactional test execution listener. Yes. And our listener that was added by default. So we may have this flexibility of isolating some behavior for testing in our listeners, be more flexible than using the classical before each, after each, before all, after all methods that exist in JUnit 5. And we have to keep in mind that we have to manage a little how to work, what to do with the default listeners. Because if we come with our own listener, the default ones will not be automatically registered. And we demonstrated that we really need them. So this is about listeners. One more thing is about being flexible, testing on different profiles. And what we can do for this, I have here another application. I used here another project, but it is practically the same application, a little modified. What we demonstrate here with the help of Spring Boot at its configuration, we can use profiles. And here in the dev profile will have one configuration. We may say, as a developer, I would like to work mostly with H2 because it is quick. And when we go to production, we would like to move to MySQL because that is the real database. And let's say that now we are really developing and we are during development. And I say, let me execute this test. I would like to demonstrate that we are using indeed the dev profile so that our execution will be on the H2 database. You see here that I have added both the dependency for H2 and there is also the dependency for MySQL so that I can immediately work with both of them. So you see here that this was executed, the test, but if you like, you see, I'm using this dialect because I'm in the development. I want not to waste time, so I would like to use a quick in-memory database. But when I go to production, what can I do? I can simply switch from here to the prod profile. I also have an alternative because I mentioned this active profile annotation. I can switch from here, and you should know that this annotation will override this default behavior. But most likely you will not. You would like not to touch the code. So you have both alternatives, but you would like to separate. In most cases, you would like to separate the configuration from the code. And now I am running on the prod profile. And if I go here, you see here that by simply moving to that profile, I also switch to this MySQL configuration, which is detailed here. Okay, so I say I have this alternative of working with active profiles as it is written here on the slide, but the quickest is to change in the configuration. And one more thing here to demonstrate about testing Spring REST. We have another application from which I would like to test the HTTP API from the controller. So if I go here to this application, I have a separate application here for which I have these users, user repository. Users are participating to an auction. Yes, I'm loading the users from this CSV data loader is taking care of loading the users. And I want to have a REST application. I want to test it. How can I do this? I can test manually, of course, but this is not my purpose. I can test the real application so that if I start it, I'm looking here. It started on port 8081. Yes, I see that I have these users in my application. I have 20 users from 0 to 19, and I can go here and I can say, let me test from some REST execution. And IntelliJ IDEA allows me to go with these commands here. And I may say, let's change a user by patching it. Yes. And then I may say, let's see that the user number 4 that you patched was updated and was modified. And let's try to add a new user here. I say Peter Mikkelsen. I can even check it from here. So I may have Peter Mikkelsen added user 20. So I have from 0 to 20, 21 users. I may check it from here. So this is at least partially automated, but it has the disadvantage of needing pretty much code. And besides it, it needs our application to be up and running and we are interacting with the real database. And one alternative to use Spring integration testing with Spring is to write this test with mocks. Also, I'm writing here a Spring Boot REST test, a Spring Boot test here, and I'm saying what is my purpose. My purpose is to test what? This user controller. Yes, I would like to test the functionality of this user controller. How should I test it? I should test it independently of the database. So I'm writing here this user repository is mocked, and I'm annotating it with this mock bin in order not only to mock it, but to add it as a bin to the Spring context. Here, in order to configure the things, I am going to say auto configure mock MVC. I'm importing the data from this CSV loader that I said it is taking care of importing data. And for all my tests, I will instruct how this user repository behavior that is mocked should be. So I'm saying whenever I will ask you find all, give me this mock answer. Then try to perform something against the REST API and verify that or this. Test user not found, so I am trying to get a user that does not exist. I'm mocking the behavior of the user repository and consequently of the database, and I am performing these actions against the HTTP API. And in fact, what I'm testing here is the behavior of the user controller, but disconnected from the database. So I would like to be loosely coupled with the database, and consequently, I want my tests to be on the safe side. I want my integration tests not to depend on the real database and not to have problems because of it, to need to have that database up and running and to take care about cleaning it. So this demonstrates also the testing of Spring REST interface. So this concludes our demonstration. I know we are a few minutes, 2 minutes after the official ending time, but I wanted to cover everything. Remember that you may find here the code on my GitHub. Remember that you may get in contact with me through LinkedIn or through Twitter. You will easily find me. And please, if there are questions now, I'm ready to answer.